Hi, hello friends, welcome to our channel Study of Mathematics.
Hi, hello friends. Welcome to our channel Study of Mathematics. In this video, we will discuss about the basic concepts of mathematics. Mathematics is nothing but a numbers. First, we know about the number system. First, we know about the number system. In this number system topic, we will learn what is number system, what are the charts are there in number system. That means what are the different stages or different types of number systems are there, we have to learn in this video. Then in that, first we see this chart. Here is the chart. In this number system is the basic backbone of the maths, and this number system is and this number system is about that. This number system is that uh, first we have to derive number system is nothing but a complex numbers, is nothing but a complex numbers. And these complex numbers again we have to divide into two types. Again we have to divide into two types, that are, here is that, real numbers and also imaginary numbers. Real numbers again we have to classify into two types, that is rational numbers and irrational numbers. Here real numbers are indicated by the letter capital R, and here rational numbers and irrational numbers are there. Rational numbers are indicated with the letter Q. Rational numbers indicated with the letter Q, and irrational numbers indicated with the letter Q bar. And integers, rational numbers again classified into integers, fractional numbers. Integers are indicated with the letter capital Z, and integers again classified into two, but that is whole numbers and negative numbers. Whole numbers is nothing but a capital W, and whole numbers again classified into natural numbers and zero. Natural numbers are indicated with the letter capital N, and in natural numbers we know that all the natural numbers are counting numbers. The natural numbers are having the so many types of that. In that, some of are even numbers, odd numbers, prime numbers, composite numbers. First, we learn about the natural numbers. Here is that, what is the natural numbers, and first, what is mean by natural numbers? The set of counting numbers from 1, 2, 3, 4 and so on are called as natural numbers, and all the natural numbers are denoted by the letter capital N. And the set of natural numbers can write it as a capital N is equal to set of 1, 2, 3, 4, 5 and so on. In these natural numbers we have so many infinity number of numbers are there, and the some of the important points about natural numbers are the difference between any two consecutive natural numbers. Any two consecutive, here the word is consecutive is there now. Consecutive is nothing but a the next number. The continuation of numbers are there now. In that, the continuation of numbers, the difference between any side by side number is difference is equal to 1. That means here in these natural numbers 1, 2, 3, 4, 5, 6 and so on are there now. For example, we take 1 comma 2 are the two consecutive integers or consecutive natural numbers. The difference between the two numbers, biggest number minus smallest number, is equal to 1. This is the difference between any two consecutive natural numbers is 1. In the same way, we take any number 99 minus 100. Here 99 sorry 100 minus 99. don't take 99 minus 100. We take it as a 100 minus 99. 100 minus 99 is equal to 1. This is the consecutive number. Consecutive natural numbers difference value is equal to 1. That means if you take any two numbers, any two consecutive natural numbers, we take it as a difference. That means subtraction of the two numbers, we get 1 only. And the sign of natural numbers is positive only. And properties of natural numbers are, some of the properties are there, we know that already, that is closure property, commutative property, associative property, distributive property, and some of the other properties also there. In that properties, for natural numbers, always closed commutative and associative under addition and multiplication, and natural numbers are not closed commutative and associative under subtraction and division. In the same way, multiplication of natural numbers is always distributive over addition and also subtraction. These are all about the properties. First, here is that first we have to know about the closure property, or that is a closure property. Closure property. What is meant by closure property is nothing but, if you take any two numbers, we have to discuss about the natural numbers now. Then we take any two numbers, that is I am taking a comma b, or in the set of natural numbers. That means these two numbers, either 1, 2, 3 and so on, all the set of natural numbers are there now. These two numbers are any two natural numbers, and closure property is nothing but according to the addition, a plus b is also belongs to n. That means the addition of two natural numbers is again one of the natural number. Then these two numbers a comma b satisfies closure property according to the addition, and according to the subtraction we have to, closure property satisfies means a minus b is also belongs to capital N. For this, first we take it as a 2. Example, take 1 comma 2 or the set of natural numbers. Now, in this you take 1 minus 2. Here a 1 minus 2. We know that 1 minus 2 value is equal to minus 1. Minus 1 is not belongs to the set of natural numbers n. That means the set of natural numbers are could not satisfy the closure property under the subtraction. That means if any two numbers are satisfies the closure property according to the subtraction, that means if a comma b or any set of n numbers, set of natural numbers, that means the product of the two numbers also belongs to the n only. And in the same way, a divided by is does not belongs to capital N, because if you take the same number 1 comma 2, 1 divided by 2, that means 1 by 2 is equal to, we know that 0.5. 0.5 is not a natural number. Then these two numbers could not satisfy the closure property according to the division. Then the closure property satisfies only under the addition and under the multiplication only. Next, we have to discuss, next topic is commutative property. Commutative property. All these properties we have to satisfies only under addition and multiplication. Next property is that commutative property. Commutative property. That commutative property is nothing but that any two numbers we take it a b belongs to n, then commutative property is nothing but according to the addition I am telling about that, a plus b is equal to b plus a. If you add any two natural numbers in any a plus b is equal to b plus a, then these two numbers a comma b belongs to n or satisfies the commutative property under addition. In the same way, this commutative property is also satisfies under multiplication also. If you take any two of the numbers 2, 3 or belongs to the set of natural numbers, then 2 plus 3 is equal to 5 and also 3 plus 2 is equal to 5. These two numbers are equal now. That's why this property satisfies. In the second numbers, we have to apply for this problem. This is multiplication. That means 2 into 3 is equal to 6 and also 3 into 2 is also equal to 6. Then here also the values are equal. That means A into B is equal to B into A. If you take the same numbers 2, 3, then you take the according to the subtraction 2 minus 3 is equal to we get minus 1 and 3 minus 2 we get plus 1. These two values are not equal to each other. That means the set of natural numbers would not satisfy commutative property under subtraction. In the same way, division also 2 divided by 3 and 3 divided by 2. These two values is not equal to each other. That means here commutative property only satisfies the commutative property satisfies according to addition and according to multiplication only satisfies. According to subtraction and division, there is no satisfaction for this commutative property. Next property is that associative property. The next property is associative property. Next property is associative property. Associative property. Here for this associative property, we take any three numbers. For closure and commutative, you take only two. Na? For this associative property, you take any three numbers or in the set of, I am taking it as C also, A, B, C or in the set of natural numbers, then A plus B plus C is equal to A plus of B plus C. That means here A plus B plus C is equal to A plus B plus C. Then if this equation satisfies the any three numbers of the natural numbers, then we say that associative property satisfies them. Associative property satisfies according to the addition. For example, you take any numbers 2, 2, 8, 7. 2, 8, 7. That is any three numbers you take that, but that all the numbers belongs to n only you take. Here 2 plus 8 plus 7 is equal to how much? 2 plus 8 10. 10 plus 7 17 and also you take 2 plus of 8 plus 7. That means 2 plus 7 plus 15. 2 plus 15 is 17. Then these two equations are equal now. That means this LHS value is equal to RHS. Then all the natural numbers satisfies the associative property according to the addition. And in the same way, according to the multiplication also we satisfies this property. That means A into B into C is equal to A into B into C. Then according to the multiplication also satisfies associative property. If you want, you check by taking any three natural numbers and but A minus B minus C is not equal to A minus of B minus C. And in the same way, A divided B divided by C is not equal to A divided B divided C. These two equations are not equal. Then the natural numbers would not satisfy the associative property under subtraction and under division. That means all the natural numbers are satisfies the associative property under addition and multiplication only. Could not satisfy the under subtraction and division. This is about associative property. Next we go. Next is distributive property. For this distributive property also we take any three numbers, that means I am take it as a b c or in the set of natural numbers. Then what is meant by distributive property? The distributive property according to the multiplication and addition is there, multiplication and subtraction is there. For the first I am explain about the distributive property according to the under multiplication and addition. That means a into b plus c is equal to ab plus AC, AB plus AC. And for distributive property under subtraction is A into B minus C is equal to AB minus AC. These two equations, that these three numbers are satisfies these two equations, then we say that the set of natural numbers are satisfies distributive property under multiplication addition and multiplication subtraction. That means the multiplication of natural numbers satisfies the distributive property under addition and also in the under subtraction also. For this, first we take, for example, take, I am taking 2 3 5. That means you take any three of the numbers. These three numbers are natural numbers, we know that. Then for first equation I am satisfying. First LHS is 1 into 2 plus 5. That means 1 into 7. That is 7 only. In RHS AB, that means 1 into 2 plus 1 into 5. That is equal to 1 into 2, 2 plus 1 into 5, 5. That means 2 plus 5 is 7. Then LHS equal to RHS. Then this equation satisfies. And also in this, and according to the subtraction, 1 into 2 minus 5 is equal to 1 into minus 3. That is equal to minus 3. And 1 into 2 minus of 1 into 5, that means 2 minus 5 is equal to minus 3. Then these two values are also equal. Then this distributive property satisfies. If we have a doubt, that is these two numbers are negative, these two are the not natural numbers, then how satisfies? That is not a problem. You take only the natural numbers, the result would be the any numbers. We have any numbers, but we take only. Next we know about the whole numbers. The whole numbers is nothing but the set of natural numbers. Already we learned, we have to completed understanding that all the natural numbers along with 0 are referred to as a whole numbers. These whole numbers are indicated with the letter W. That means here we know already 1, 2, 3, 4 and so on, all of the whole natural numbers. For this whole natural number set, we add only the number 0. Then we got whole number set. That whole numbers are indicated by the letter capital W. And one of the most important point is that all the natural numbers are whole numbers, but all the whole numbers are not natural numbers, because here first we understand the half of the part. All the natural numbers are whole numbers. We know already natural numbers is set of 1 2 3 4 and so on. These are the natural numbers. These are all natural numbers or in the set whole number, but all whole numbers are not natural numbers. That means whole numbers are start from 0 1 2 3 and so on are there na? But these are all natural numbers, but 0 is not a natural number now. That is the meaning of that sentence. That means all the natural numbers are whole numbers, but all the whole numbers are not natural numbers. This is about natural numbers and whole numbers topic. Next we discuss what is mean by even number, what is mean by odd number, and what is prime number, and what is composite.
Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.